Today I am going to talk about Subrahmanyar Chandrasekhar. He was an Indian astrophysicist and one of the greatest scientists in the world. He was born in 19 October 1910 and died on 21st August 1995 at the age of 84. He did his BSc from the University of Madras. He did his MSc and PhD from Trinity College, Cambridge. He was one of the greatest astrophysicists who spent his professional life in the United States. He received a Nobel Prize in 1983 for theoretical studies of the physical processes of importance to the structure and evolution of the stars. He received many national and international awards, including Padma Vibhushan in 1968 and National Medal of Science in 1966. His scientific career included study in the fields of astrophysics, general relativity, fluid dynamics, radiation, and quantum theory. He married Lalita Doraiswamy in September 1936. She was a fellow student at Presidency College. Many considered him as a warm, positive, generous, unassuming, meticulous, and open to debate. In 1928, Subrahmanyar Chandrasekhar set sail for England to study at Cambridge University with the British astronomer Sir Arthur Eddington, an expert on general relativity. Chandrasekhar worked out how big a star could be and still support itself against its own gravity after it had used up all its fuel. The idea was this: when the star becomes small, the matter particles get very near each other, and so, according to the Pauli exclusion principle, they must have very different velocities. This makes them move away from each other and so tends to make the star expand. A star can therefore maintain itself at a constant radius by balance between the attraction of gravity and the repulsion that arises from the exclusion principle. Chandrasekhar realized, however, that there is a limit to the repulsion that the exclusion principle can provide. The theory of relativity limits the maximum difference in the velocities of the matter particles in the stars to the speed of light. This means that when the star got sufficiently dense, the repulsion caused by the exclusion principle would be less than the attraction of gravity. Chandrasekhar calculated that a cold star of more than about 1.5 times the mass of the Sun would not be able to support itself against its own gravity. This mass is now known as the Chandrasekhar limit. In other words, the maximum possible mass of a stable cold star above which it must collapse to a black hole. This mass is 1.44 times the mass of our Sun. This had serious implications for the ultimate fate of massive stars. If a star's mass is less than the Chandrasekhar limit, it can eventually stop contracting and settle down to a possible final state as a white dwarf with a radius of few thousand miles and density of hundreds of tons per cubic inch. Chandrasekhar supervised 45 PhD students. After his death, his widow made a gift of his Nobel Prize money to the University of Chicago. Carl Sagan praised him in the book The Demon Haunted World like this: I discovered what true mathematical elegance is from Subrahmanyar Chandrasekhar. On October 19, 2017, Google showed a Google Doodle in 28 countries honoring Chandrasekhar's 107th birthday and the Chandrasekhar limit. Such was his contributions to the scientific world. We are all proud of him. I hope you have liked this scientific story. Earlier, I have already made an episode about him in Hindi, giving interesting facts about him, the link of which is given in the description. Don't miss it. Also, thank you for listening to these achievements of our great scientists. Don't forget to share this video, for knowledge must spread. Thank you, everybody. Thanks a lot.